Hello and welcome to this conversation with Eric Org and Vivek Vadakupatu from Azimuth Systems. I am Frank Raya. This conversation is part of a SenzaFili report on deployments of heterogeneous networks that give an update on the latest solutions from the wireless ecosystem that will make headnets a reality. Today we're speaking with Eric Org, Director of Product Management Lab Systems, and Vivek Vadakupatu, Director for Test Plan Solutions. Both are with Azimuth Systems. Azimuth is a leader in mobile performance test solutions for network operators, device OEMs, chipset vendors, and infrastructure providers. So I would like to start by welcoming you, Vivek and Eric, to this conversation. Thank you for joining us today.
Thanks, Frank.
Thanks, Frank.
I would like to start, maybe I'll start with you, Eric, to ask you to give us a brief overview of Azimuth Systems.
Well, Frank, Azimuth Systems is all about providing real-world test solutions. And what I mean by that is one of the biggest challenges operators, device vendors, infrastructure vendors all have is testing their products in a way that reflects how the end users actually experience them. And so what Azimuth offers is a suite of products, platforms, and solutions that help our customers replicate real-world performance in the lab. It all starts with some of our core platforms like our ACE channel emulator. And with our ACE channel emulator, we can recreate the propagation conditions that exist between any particular piece of infrastructure and a handset. With that, we use automation and we use test plans developed by my colleague Vivek's team in order to provide end-to-end solutions that can really provide our customers the data and the measurements that matter to them, and that is end-user experience. Maybe Vivek, I could ask you to add something about test plans and how that really fits into Azimuth's mission.
Yeah, thanks, Eric. I think, as Eric mentioned, the focus at Azimuth Systems is really about qualifying, real-world performance, testing devices, networks in real-world conditions with real-world applications. So my team takes the products and the platforms built by engineering, and we create what are called as test plans. So the way to look at it is almost like Lego blocks. So you have all these products which are like individual blocks, and you can combine them to build a building out of it. So basically, with a test plan, what you do is you sit down with an operator or anyone in the ecosystem for that matter, try to figure out what problem they're trying to solve. Someone might tell, I want to roll out VoLTE. Once you know what the problem is that they're trying to solve, you come up with a bunch of test scenarios and come up with an automated solution that helps them roll out this technology in an efficient, timely manner.
So when we're talking about new technologies and new architectures, headnets are now a major focus for the industry, and there are a lot of benefits that come along with headnets, mainly capacity. But there are also some challenges. What do you see the main challenges to headnet deployments from your perspective, being on the testing side of the wireless networks?
Well, maybe I could start to address that, and I would immediately point at the fact that features and technologies like headnet are multi-link technologies. They're technologies that require multiple simultaneous links between pieces of infrastructure and terminals in order to deliver the best overall average performance to all the users of a network. And to things like headnet, I would also add carrier aggregation or multi-user MIMO. And so the fundamental challenge is simply that you need a hardware platform that can support multiple links at one time. And that's, from my perspective, in terms of lab products, that's what I'm really focused at delivering for Azimuth, are test beds that can support these multiple links. And so in the example of a headnet, the smallest test bed you might want to consider might have 2 to 3 femtocells and 2 to 3 macro cells. Because if you thought about a typical deployment, there might be a home node be adjacent to a second home node be. And so when you're trying to look at the performance of a UE that's within the coverage area of a femtocell, that UE is always in conflict to figure out where it should attach to. Do I attach to the femtocell in my home? Do I attach to the macro cell under which the femtocell is deployed? Or if I go near a window in my house and I start to pick up an adjacent femtocell or a further macro cell, you know, what's the best piece of infrastructure for my terminal to connect to? And so this is all part of the decision making that the network, that the service providers have to offer in order to ensure the best average performance for all the users, not just that one particular user in the house, but all the users that are attached to the macro cell and other users that are attached to adjacent femtocells. And so I think that certainly presents problems or challenges for test plans. So as I mentioned, my team would provide this fundamental platform, and then once again, I'd look to Vivek's team to offer a test plan that could enable that. And in fact, one of the things I know Vivek is working on are test plans for small cells. So maybe you could talk to that, Vivek.
Yeah, thanks, Eric. So I think with headnets, I think there are two fundamental dimensions or two fundamental aspects. The first thing is technological challenges. So, you know, a very good example for that is, as Eric told, more and more operators are embracing the concept of small cells. I think there is a term in the industry called network densification. Now, while there are advantages, one of the fundamental challenges we see is a very common scenario where you go, you know, you're outdoors, you go inside your apartment. So what happens is your device goes from a macro network to your femto network. And then the device gets into this mode where there's a ping pong between the macro cell and the femto cell. That leads to very disruptive behavior of the device, and the user experience is not very good. So you have inherent technical challenges like that. Apart from the technical challenges, the second aspect to it is the whole complexity. Think of it this way. Earlier, if I just looked at homogeneous networks, I'm just looking at cellular, all your handovers were just between 3G to 2G, and it was all macro to macro. Now what happens is you took what was a one-dimensional problem and you made it 2 or 3-dimensional, because it's no longer just cellular. There's cellular to Wi-Fi handover. It's macro to femtocell handovers. So the number of permutations and combinations increases exponentially. And the fact that this, combined with the fact that technology by itself is becoming more complex, makes it very, very difficult for pretty much anyone in the ecosystem, whether you're deploying a headnet, heterogeneous network, or whether you're developing a device or infrastructure equipment that's going to sit in a heterogeneous network, to do your testing so that you cover all the corner cases. That is why the focus of the test plans that my team, that I developed, is really to make sure that you cover all the typical corner cases. And one of the reasons we are able to do this, or I should tell 2 reasons we are able to do this, is because of automation. So if I have 40 different scenarios that I have to cover, doing it manually, like how the industry used to do it 10 years back, when you just had 2 combinations, is no longer scalable. So automation is a very big piece of what we do. And the second thing is, as I mentioned, as testing increases, the number of permutations and combinations increases, it becomes imperative that you choose tests that really help you pick out issues. So the second thing is making sure that whatever tests you run helps you catch an issue that you won't be catching otherwise. And we do this through our real-world testing expertise.
So obviously then, yes, densification is critical, and you mentioned about the multi-links. How do you actually take that from the complexity of the network and bring it into the lab? How do you achieve that with your solutions and with your approach?
Yeah, well, we have a couple tools that are really designed to help do that, because as the test beds get more complex, it's very easy for our customers to get caught up in just the mechanics of building the test bed. And building a test bed doesn't solve problems for them. They need to actually use the test bed and collect data and have it presented in a way that's easy for them to analyze and assess. So to help them do that, most recently we're working on a tool called the multilink scenario application. And I guess the name is a bit self-explanatory, but really it's a tool designed to help our customers build scenarios that reflect multiple links, so multiple eNode Bs connected to one or more UEs. In particular, we're looking at scenarios for both carrier aggregation and headnet, but essentially we'll give customers visual cues to let them choose between coverage situations with one or more eNode Bs, and on top of that, we'll overlay mobility paths. So we'll give them choices for the UE to move that simulate everything from handovers to, in the case of carrier aggregation, secondary cell attach and release events. And so by presenting this in a very easy to use fashion, we let customers create scenarios which can be immediately replayed on my ACE channel emulator. And we do that through another tool called Field to Lab. So part of Field to Lab is playing back a file created either with the multi-link scenario application or a file which we created from a drive test that was recorded by somebody using a diagnostic monitor such as QXDM or through a hardware scanner like a JDSU scanner in the field. And so we take either of these inputs and we can then directly replay these field conditions on the channel emulator such that our customers can recreate real-world scenarios in their lab. And they can do it in a way that reflects multiple links for headnet or carrier aggregation, or an individual link if that's really their test goal.
When it comes to your solution set, obviously you had to make some decisions and choices on what to build and what to do and the approach you take. What differentiates your approach from other type of tests and solutions for testing that are available on the market?
I think there are, Eric can add to this, but I think there are two things, and I touched on this earlier, two things that I think really differentiate us. The first thing is our goal is really in performance testing. If you look at the industry as such, testing is broadly broken into performance testing and conformance testing. The products that we have right from day one are conformance ready, but we spend a lot of our time in developing solutions for performance testing, because at the end of the day, what a customer remembers is the exceptional, it's outliers, or okay, with a particular device, I got really good performance. It's not the bare minimum performance that people look at. So it's that focus on performance testing, and it manifests itself in the form of real-world testing. Our focus is real-world testing, testing under real-world conditions with real-world applications. And second thing I would tell is, more on the automation front, because as I mentioned, the number of test cases that people need to run has been increasing over the years. So instead of giving people just a single piece of equipment and asking them to run tests on our own, our goal is really to come up with automation. And what differentiates our solution is a focus on end-to-end automation. And when I mean end-to-end automation, I mean automating all the way from the base station all the way down to the handset. So this way you have the way to automate the entire system. So maybe Eric, you can add to that.
Yeah, I mean, maybe I just steal Vivek's line from the beginning of this conversation and tell you that Azimuth's products are like a bunch of Legos. So we have a bunch of building blocks, channel emulation, automation solutions, field to lab, test plans that our customers can assemble into the test bed and create the test cases that most directly reflect the real world performance that they would like to recreate, so that they can measure what matters, which is their subscribers and their customers' experience. So it really is the modularity, it's the automation, and it's our ability to provide an end-to-end real-world solution.
If we look at the LTE roadmap, most of the networks today deployed are based on release 8, and some networks now have started to implement some release 10 features. Where do you see the testing environment right now in relationship to the LTE roadmap? How are we doing in terms of tests for the LTE roadmap?
Well, I think the deployment of new technologies follows a pretty common cycle. I mean, as you deploy a new technology, the focus is initially on compliance and functionality. because how can you worry about performance unless you can create the links and the connections to begin with? So today, when we think about headnet and we think about small cells and we think about carrier aggregation, most of the testing done by the early adopters and by the first operators deploying these technologies is focused on compliance and functionality. And I would say performance in the early going is certainly important and relevant, but because only a small number of customers are using those features, performance is not yet a bottleneck. But as people start to take advantage of the benefits of a heterogeneous network, of a network with many small cells, or start to take advantage of a network with carrier aggregation, well, those network elements are going to start to become more congested. And as that happens, operators and equipment vendors are going to become more and more concerned that they're able to deliver the performance that subscribers expect. So we've seen this with the advent of LTE, where the focus was initially on compliance testing and the use of standard channel models to verify the links were set up and function properly. But as more and more people began to use those technologies and the number of subscribers on each of the networks went up, well, operators have become more focused on performance testing. And we expect it to develop in the same way with headnet and with carrier aggregation. And in fact, that's what we've seen so far. The first people deploying headnet and the first people deploying carrier aggregation are really focused on compliance and functionality. And they're only now, within 6 months after launching those features, are they starting to think more and more about performance testing.
Yeah. And if I could add to that, I think one of the unique things, or the Azimuth's position in the industry, gives us visibility at different stages of product development. So, the solutions we have, the test plans we have, touch people both in the initial R&D phases, during pre-deployment, during post-deployment. So what we see is, as Eric pointed out, you have operators who are just beginning to ramp up on release 10. So with them, people are looking at aspects such as VoLTE, aspects such as carrier aggregation. And then you have operators who've already deployed LTE networks, and there the focus becomes all about optimizing your optimizing the network that you've deployed. Things such as comp, interference mitigation. So what we find is it's almost like an assembly line. It goes through a phase. There's a temporal aspect to it, and there's also an ecosystem aspect to it, depending on whether you're working with an infrastructure vendor or a chipset vendor who starts looking at a technology much earlier than an operator.
And so really what Vivek and I try to do is get out in front of our customers' needs. So we're trying to plan for headnet and plan for carrier aggregation before there's overwhelming demand and imperatives at our customers to deploy those kinds of solutions. We are ready now, and we'll continue to grow and deepen our solutions so that as customers need performance and they start to identify problems in their network deployments, we're prepared to support them.
Some of these features that you mentioned in terms of test plans and what you test for are equally applicable to the macro cell and the small cell layers. Do you see the focus now being more on getting these features right for the macro cell layer and maybe doing the small cell layer later, or is both the macro cell and the small cell being moved in unison?
I think I think one of the interesting things we are seeing in the industry is the small cells are gaining a lot more significance as opposed to what we saw with 3G. So while the focus is still on macro cells to a great extent, the people have started looking at small cells at a very early stage. Now, when we work with operators, we work with an operator to define a test plan, to do IoT testing. Typically, if this had happened 3 years back, the focus would have been entirely on macro networks. Right now, right on day one, the operator told, I want to start with a macro network, but I want to keep in mind that a month from now, 2 months from now, I also want to start testing with small cells. So what we see is this almost a change, a new trend in the industry where small cells are beginning to gain significance not only during deployment but right from an early planning stage.
I would like to ask you about something that you touched upon earlier, and that's basically the automation of the test plans, and because of the growing number of devices and small cells. Can you detail a little bit more, go a little bit more into, give us a flavor of the type of work that you do in order to address this issue? Because it's a fairly complex issue now with multiple frequencies being available, multiple systems, 3G, Wi-Fi, LTE, and different types of devices. How can operators deal with all this mix of systems in their networks?
Yeah, I think that's a great question, and it's actually a fundamental question that led to the genesis of my team. So if you look at the challenges you'd mentioned, right? Technology's got more complex, whether it's additional frequency bands, new technologies, number of devices, the need for automation becomes very imminent. Then one asks the question, what do I need, or what does the industry offer? And that's where you find that there are very few solutions in the industry that can work across technologies or that can work across applications. It seems very fundamental, but many times what you find is you'd find one automation tool that works for voice, one that works for data, and one that works for user subscriber experience. So what we've done is, when we come up with test plans or when we come up with automation, our goal is really to make sure that we have a solution that not only works across technologies, but also works across different operating systems. If you're a user, the end user, if I'm an operator, I shouldn't have to worry about is it an Android versus a Windows Mobile 8 versus an iOS device. My goal is to get devices out into the market. So the automation we create is really a consistent platform that works across technologies, works across operating systems, works across different frequencies. And what that allows us to do is abstract all this complexity from the end user. So if I'm an operator and I want to roll out 4 new frequency bands, roll out 20 devices with 5 different operating systems, the testing I do is going to be the same regardless of what device it is, what technology it is, because all the details of the operating system, the chipset that you're using, are abstracted through the automation tools that we offer.
Yeah, I would say that automation is essentially for timely and comprehensive testing across the full range of scenarios that people need to test today. And Azimuth brings once again, this Lego analogy that we have automation for not only our own products like our channel emulators and our over-the-air products, but we have automation for third-party test equipment. We can automate a base station emulator as part of our test bed, and we can also automate terminals. So it's not just automating Azimuth, it's automating Azimuth and turning on a base station emulator to the right frequency, setting the power on the base station emulator, then automating a device to start a call or perhaps start a YouTube session or some other application so that we can do application-specific performance testing in a range of environments that we can deliver via our channel emulators. So it's really this end-to-end perspective and automation that supports end-to-end testing that really differentiates what we can do at Azimuth.
Mm-hmm. I'm going to ask you a question that's maybe a little bit, I hope it's not too difficult to answer, but is there some quantifiable benefits to the automation? Like, is there some metrics that you have in mind in terms of improvements, or something tangible that helps the operators that you can share with us?
Yeah, I think I can actually give you a very specific example. So we worked with one operator on rolling out a new test plan. So this operator used to do the same testing. They used to do IoT testing earlier manually. So the data point that we got from the customer was it used to take them 8 hours to do 10 tests. 8 hours, you have an engineer sitting there running the tests to do the same 10 tests. Using automation, they were able to run the same 10 tests in just 1 hour. So right off the bat, you are able to cut down the test time from an entire day to an hour. Now, the beauty of automation is it allows you to do testing 24/7. So what that means is I go from being able to run 10 tests a day to being able to run 240 tests a day. That is at least a 20x improvement over what you were doing manually. So that is one data point we have. And I know you asked about automation, but another thing, another area where we also look at ROI through these methods is field to lab. So maybe Eric, you can talk about the improvement customers have seen using field to lab.
Thanks, Vivek. So with field to lab, what we're able to do is capture field conditions and then replay them on our channel emulator, which means that you don't have to go back to the lab, to the field over and over again if you want to test incremental changes in software or hardware. And so we've been able to capture some empirical results from our customers that, and from that we've determined that many customers experience a 30% or greater reduction in total drive testing when they use field to lab. Field to lab doesn't replace drive testing because you still have to get out there in order to see what the real world conditions are. But once you've captured them, now we can recreate them in a very repeatable basis in the lab using field to lab and our ACE channel emulators. Another way to look at it is that for most devices, there are fairly extensive lists of tests that need to get accomplished in the field. And those tests have a cost in terms of time for the drive test team, for equipment costs to get out there. And the cost of doing a full set of acceptance tests in the field could range from $30,000 to $50,000 per device. And so by moving tests to the lab, not only can I save total test time, but I can save absolute dollars that I can reduce from my drive test budget.
Eric, how does field to lab actually work? Because that's very important. In the field, you have basically a very complex environment. How do you bring that into the lab? What exactly are you doing there to bring it to the lab?
Well, what we've done is we've designed our field to lab product to work pretty seamlessly with a wide range of drive test tools. And drive test tools range from software-based diagnostic monitors, such as QXDM provided by Qualcomm, to a bunch of hardware scanners that might be provided by JDS Uniphase, PCTEL, or other vendors. And each one of these drive test tools creates a log file. And it's with that log file that we begin. Those log files contain everything from RSRP to signal to noise to CQI, basically all the measurements of RF performance and of the RF propagation environment that the terminal or the drive test tool were able to capture over the course of a drive test. And so I take that log file now as the input to my system. And we do a couple things with it. First, we can apply some algorithms to filter and smooth the data because not every drive test is perfect. Sometimes there's gaps in the data, sometimes there's outliers. And so first we fix that. But then we provide means to visualize and assess the drive test. So everything from a histogram reflecting distribution of RSRP, to distribution of signal to noise, to a maps interface where we can show you where the drive test occurred. So the nice thing about this is that as events happen during the drive test, you can quickly pinpoint them using our tools, and you can see the RF conditions that existed both before and after the event occurred. So that's the first half. The second and probably more significant piece is that during the drive test, you saw 1, 2, maybe 10 sectors, but the test bed that you have to recreate it on might only have 2. So somehow you have to make the mapping and the selection to say which of those 10 sectors you'd actually like to recreate and which will be meaningful for the playback in the lab. So we have both algorithms as well as custom controls for the users to go and determine which of the sectors they'd like to map to the test bed and replay. So once we've done that, the output of AZ Mapper, we call it a player file, and the player file is something that can be streamed in real time to my ACE channel emulator in order to recreate those specific field conditions. So field to lab, self-explanatory, start with the field, create a log file, map the log file using AZ Mapper, and while you're doing that, you can both visualize and assess the field conditions that existed during the drive test, and then map them so that it can be replayed on the specific test bed that you have deployed in your lab.
All right, thanks. One final question to both of you would be, what's your vision and roadmap for the future for these products and services?
Well, I think for all our products, the goal is what we started out saying, and that's really to deliver the best real-world measurements for our customers in their lab. And to do that, we see environments becoming more complex, more bands, more frequencies, more protocols, more links. And so we need to deliver the underlying hardware to recreate those test beds. And then on top of that, we have to build the end-to-end solutions that deliver the measurements and deliver the solutions that our customers require. So from a hardware perspective, we're trying to look forward and say, how do I grow my hardware platform so that I have added capacity to support additional links? And that's part of Azimuth's roadmap, is to look forward and deliver the next generation channel emulator. So we're working on that. In terms of things like field to lab, we're looking to expand our coverage so that we can support the key drive test tools used by our global customer base. And for over-the-air products, we're looking at delivering ever more capable over-the-air solutions. We didn't talk much about that, but my over-the-air solution is based on a reverb chamber and is paired with my channel emulator to recreate real-world conditions in an over-the-air chamber in the lab. And we have a vision to grow the capability there. Today, that's downlink only single sector, but we'll grow that over-the-air solution to support multiple sectors, to support advanced features like carrier aggregation. And that roadmap will be implemented over the next 6 to 12 months. I know Vivek has plans to grow his test plan coverage as well, so maybe I'll turn it back over to Vivek.
Thanks, Eric. So I think the roadmap, as I see, has two aspects to it. The first aspect is, increasing coverage, and this could be in terms of the kind of tests you run, the kind of technologies you support, or the operators that you work with. So that is one dimension to it. The second aspect of it, which to be honest with you is really what excites me, is a fundamental paradigm shift that we are moving towards. Azimuth as a company, if you look at the history of Azimuth, we started as a channel emulator company. And from channel emulation, we became what we call a solution company, where we told it's not enough if we give customers just a channel emulator. Let's give them a solution. Field to lab is an example for a solution where you look at a problem a customer has and give them a means to solve that problem. And then came along test plans where you bring in all this automation so that you tell, now I have the ability to bring a field condition into the lab, run a test, and give you a pass or fail. The paradigm changing thing that we are doing at Azimuth is actually moving from just running a test to actually helping you figure out why a test gave you some results. What I mean by that is, today you run a test, you see a device performing poorly. So people don't know why the device performs poorly. If I'm an operator, all that I see is I get a new device, the device doesn't work well. Then I take the device, give it to the OEM has to debug what's going on. So what we are trying to do from a roadmap standpoint is move from just telling a customer something went wrong to actually telling the user something went wrong, and I think it could be related to X, it could be related to one of these areas. So this way you make it easier for customers to do root cause analysis. And the reason we do this, Frank, is if you look at the entire time it takes for operators or people to roll out new technology, significant amount of time goes off in just triaging issues. And by helping customers figure out what went wrong and by making it easier for people to do root cause analysis, not only are you accelerating the actual testing, you are also accelerating the fixes for the process, thereby shortening the entire process.
All right, very good. Thanks, Vivek and Eric, for this candid conversation. I would also like to thank the viewers for watching this conversation with Eric Org, Director of Product Management Lab Products, and Vivek Vedakupatu, Director of Test Plan Solutions, both from Azimuth Systems. This conversation is part of a SenzaFili report on challenges to headnet deployments that provides an update on the latest solutions from the wireless ecosystems, which will make headnets a reality. The report can be downloaded from the SenzaFili website at www.senzafiliconsulting.com. Thanks again, Vivek and Eric.
Thanks, Frank.
And goodbye.
Thanks, Frank. It was a pleasure. Have a great evening.
Thank you.